Okay, we are here this evening for a virtual presentation to tell you a little bit more about geology. So I'm going to go ahead and let Dr. Maurer introduce himself and the students that are joining us, and we'll go from there.
Fantastic. Thanks, Donna. So my name is Dr. Jeremy Maurer. I am an assistant professor in the Department of Earth Sciences and Engineering here at S&T. I'm in the Geological Engineering and Geology and Geophysics programs, so associated with both degree programs. And we actually have 3 majors altogether in our department. So I thought I'd just talk a little bit maybe about some of what I do, maybe about some of the career paths that you can have in geology and geophysics. And then I'll turn it over to the students who are here, who are excited to share with you about some more details about the program and again, something about future paths and directions. Obviously, I'm an academic, I'm a professor, and that is one of the possible career paths that you can take as starting out with a major in geology and geophysics. So you can kind of go an academic route, and that would involve starting out as an undergraduate, doing some geology, doing some geophysics, and then kind of progressing through to graduate school, where you would do maybe a master's and then ultimately a PhD in some specialty field. So geology and geophysics, that's pretty broad. You can do, so my area of research is earthquakes and volcanoes and natural hazards and geodesy. And so that's kind of a niche within geology and geophysics. Other folks work on environmental applications and hydrogeology. Some folks are structural geologists and look at things like faults and geologic structures. Some folks will actually look at the boundaries between the Earth and other systems like our atmosphere. And so we'll look at, actually there's a whole section in our annual conference, which is focused on the planetary boundary layer, it's called, which is that interaction between Earth's atmosphere, the near surface part of the Earth, and then the subsurface, and how those things interact with each other. So really a broad range of topics and fields. And there's an equally broad range of kind of directions to go. So academic is one route, but there are lots of jobs in the government. So I work with folks at the United States Geological Survey, as well as folks at the National Geospatial Intelligence Agency. Both of those places have former graduates from our program working at those locations. There's a Missouri Geological Survey focused on the state of Missouri. There are a bunch of national labs, so kind of other types of government work, Sandia and Los Alamos, Lawrence Livermore, Lawrence Berkeley, lots of different national labs that hire geo-type people. And that could be anything from, again, looking at kind of groundwater resources, looking at natural hazards, or it could even be doing slightly more applied things. For example, at Lawrence Livermore, I have a colleague who does nuclear bomb test tracking. So they actually use the same kind of instruments that we use to study earthquakes, and they look for people setting off nuclear devices around the world, especially in places like North Korea or other places like that, where they want to keep track of what's going on in those locations. So lots of different, a whole range actually of different possibilities for you in geology and geophysics. Another pathway is to go into industry, and there's lots of folks doing that. One of the big growing industries right now is what's called Earth observation. And so this is folks using satellite data, remote sensing data, to study how the Earth's surface is changing, how the Earth's climate is changing, and how that might affect things like ecosystems and structures, like we talked about a bit ago, how those things are all changing in response to climate change or in response to various things that humans do. So lots and lots of different possibilities and options in this field. Geological engineering, I'll just mention real quickly, that's another program we have here, and that's kind of a subset which is more focused on engineering applications of geology, but that's another kind of option, for example, for graduate school if you start out in geology. I think that's about all I have to say, so maybe I'll let the students take it over and introduce themselves and then talk through their presentation. Thanks.
Bye. Thank you, Dr. Maurer. So I'm Zach Weiss. I'm a senior here at Missouri S&T in the Geology and Geophysics department.
I'm Cale Niddle. I'm a junior in the Geology and Geophysics department.
I'm Justin Grunler. I'm also a junior in Geology and Geophysics department.
And we're going to share our presentation about our 3 departments that we have to offer in the earth science and engineering. So let me share my screen and get ready to go. Let's go here. All right. So we are the earth science and engineering department. So we're going to discuss who earth scientists are and who earth engineers are. What do we do? Where do we work? And where can you sign up at? So what do earth scientists study? We study the earth structure and global tectonics. Geoscientists study earth structure, particularly at the large scale level, such as tectonic plates, faults, and folds. This helps in understanding deformation processes and tectonic histories. Methods include data mining, machine learning assisted seismic tomography, and geodynamic modeling using high performance computers, which we have here at Missouri S&T. We study the shape and the surface of the Earth using data collected by satellites, drones, planes, and by this we can study the surface and the shape of the Earth because we know that the Earth isn't a perfect sphere. It's not a perfect ellipsoid, but it's closer to an ellipsoid, but again, not a perfect ellipsoid. This leaves us with a better understanding of water dynamics, plate tectonics, and various Earth-related hazards. We study the stratigraphy and paleontology. Geologists study the rock layers, stratigraphy, and fossils paleontology to understand Earth's history and evolution of life. Combined with information on Earth structure, we can begin to reconstruct what the Earth was like thousands, millions, or billions of years ago. And a couple of our facilities here, I think it should be showing, but Dr. Yang is behind this, and he's one of our professors here, our sedimentologist and stratigrapher. And we also have Dr. Franca here, expert paleontologist with a former student, Emma, and I assume they're looking at a fossil right there. We study hydrogeology. Geoscientists study the distribution, movement, and the properties of groundwater. By doing this, we aid in the water resource management, contamination studies, and understanding of natural processes like aquifer recharge. So what?
All right, so some of the stuff that you can do with a earth science degree once you get it. So mineral and hydrocarbon exploration is a big part of that. It's one of the more financially lucrative jobs that you can get with your degree. So they'll explore and determine the location, size, and quality of mineral and hydrocarbon deposits. There's a high demand for exploration and extraction of critical minerals in the U.S. right now, as they become more prominent in manufacturing and other uses. And then methods include field observations, laboratory tests, and using geophysical tools to find those and extract them and everything. And then a saying that goes along with it is, if it can't be grown, it must be mined. So it's always a growing field that definitely is a good opportunity. Good. Another field that you can go into is environmental assessment. And through this, geoscientists will look at the environmental impact of human activities. They do that to help ensure that projects meet environmental regulations and standards. This can include understanding the geology of waste disposal sites or potential impacts of mining. So you'll look for whether there's leftover hazards in the groundwater or contaminating different sites that need to be cleaned up and sort of. Another one is geohazard assessment and monitoring. So this is kind of along the lines of what Dr. Maurer was talking about. So they'll look at risks related to Earth, such as earthquakes, landslides, volcanoes, flooding, hurricanes, all that sorts of stuff, and provide input on safe building practices, land use planning, and disaster response. We have some research going on here at S&T down in Guatemala, looking at fault and whether or not it's going to be a risk for future landslides if an earthquake occurs, right? And stuff like that. Climate change is another big part. The earth science and engineers they're at the core of understanding our changing climate. They are able to analyze past climates using data from tree rings, ice cores, sediment, and more. They examine current climate trends and use models to project future climates. So this is a really big piece of what people are working on right now due to the ongoing effects of climate change and how that's going to affect our future and everything like that. And you can see in some of the pictures we have Dr. Farner down there on the bottom with one of his sediment cores from the ocean, I believe. And yeah. Another big one is planetary geology. They study the geology of celestial bodies such as planets, moons, and asteroids. Geoscientists in this field utilize tools like remote sensing and data from space missions to understand the geologic history and processes on other planetary bodies. This goes into like potential mining of asteroids, for example, or setting up colonies on other planets that could be really useful in the future if we're able to develop the technology to do so.
And so,
yeah,
how? So what do our scientists do? We do a lot of field work. Geoscientists frequently conduct field work to collect samples, make observations, and record data. You can pretty much travel anywhere in the world, as you'll see. As you see to the right, you can see Arches National Park, Cape of Good Hope in South Africa. I believe that's Bryce Canyon, and then the Great Pyramids of Giza on the right there. They can involve collecting rock samples, taking measurements of the rock structures, and creating maps of the study area. All those are super important to field work, especially geophysical data. That's the subsurface. So you're going to be taking seismic measurements, gravity data, magnetic data, things of that sort. All good data measurements when you're trying to understand the Earth. And so here we have one of our faculty, Dr. Yang. He is doing research in northwestern China, looking at oil shales and a Rift Lake. And this is this past summer he was there. We got a couple other people from other universities there with him doing some research, I'm assuming. Yeah, so pretty much you can travel anywhere. It's one good example. This is Dr. Oberst Farner and his crew down in Guatemala, some of his crew down in Guatemala, taking a break, eating lunch. They're out there mapping some of the jungle for research purposes, trying to set up seismometers, things of that sort, helping or doing research on climate change as well, where to take core samples to analyze the core samples. And so, you know, to know the rock, you must see the rock. You must become one with the rock. The students here, they're looking at rocks with their hand lens in order to look at maybe the mineral composition, grain size, see if there's what kind of sorting there is going on. And so they're out there doing the field work. That's one really good thing with a lot of the classes that we offer here is that you're not just dealing with theoreticals and hypotheticals. You're actually going out there into the field and hands-on learning experience. And then that's super beneficial that a lot of other degree programs are not going to offer. And so another thing that earth scientists do is geophysical surveys. So like I was talking about earlier, they look for the physical properties of the Earth, like gravity, the natural electrical resistivity of the Earth, and seismic wave to understand the Earth at different scales. So subsurface exploration is crucial in determining location of mineral deposits, petroleum deposits, all of those which are crucial in any sort of thing in the modern world, electronics, roads, cars, stuff like that. And so here is earlier, Dr. Maurer was on the call. He's with a student taking gravity measurements, looking for a buried cave in St. Louis. And then he's actually using a gravimeter there, sorry. And then to the right, we have Dr. Gao in Ethiopia, in Mozambique, taking measurements there. I believe he's holding an AK-47 there. During their time of research, they were in an area of conflict, but the research must go on. Dr. Liu, another great faculty here at SNT, conducting field experiments literally all over the world: Russia, Hawaii, Egypt, Botswana, Zambia. I mean, that's pretty crazy. And in this field, you can travel literally anywhere. And this is one of our PhD students doing one of his projects in Guatemala. You're looking at them installing seismic stations, and the guy actually in the tree is holding a solar panel because they're solar powered seismic stations, and so they needed sunlight in order to charge that battery up. So they're installing the solar panel up there. This is Grant and Dr. Gao in Guatemala. You can see they're drinking some milk from the coconuts, and in this green circle here, you can see that I believe that is a massive scorpion when they are looking for their seismic stations. And so a lot of geology is out in the field, but there are definitely lab positions, like stuff to do. You're not always outside. And I think that's what a lot of people fear, is that there are definitely some work inside. They perform detailed laboratory analysis on the collected samples that they got from the field, determine their mineralogy, chemistry, age, and physical properties. Some of those techniques are petrographic microscopy, X-ray diffraction, max spectrometry, and radiometric dating. The radiometric dating is, you can determine the age of the Earth from that. So that's pretty interesting. So who would give me a job? That's the big question everyone asks themselves. With this degree, how do I get a job? A lot of geology and geophysicists work in the energy sector. So that's like oil, petroleum industry. Those are the highest paying field. One of the more important ones is the mining and the minerals industry, looking for those critical minerals that allow us to make phones, electronics, things like that. We're going to need a lot of those critical mineral deposits if we want to keep living the way we want to keep living. Environmental consultancies are super important, making sure that buildings are going up correctly, things of that sort. You have the government agencies such as the United States Geological Survey, you have state geological surveys, and NASA doing important research there. You have marine and oceanographic institutions. You have academia, so you can come back and be professor, you can be high school teachers, work at museums and science centers, all those super important.
So I'll go ahead and take back over. So if you choose one of the 3 programs, so Geology and Geophysics, which is one, geological engineering or petroleum engineering, we're going to offer you a $4,000 scholarship for fall 2024 new and transfer students. So that is a big help towards that tuition. We conduct tasks both outdoors and engage in advanced laboratory computational analyses. So again, as Justin was saying, we're not always out in the field. If you're a lab rat, you can get jobs being a lab rat, where if you're just a complete outside enthusiast, you can always be outside in those careers. The 3 programs were highly paid. The median annual salary for us, for geologists and geophysicists, is $104,000, according to the U.S. Bureau of Labor Statistics. By 2028, there will be a deficit of 35,000 geoscientists, according to the American Geoscience Institution. The employment opportunities in geoscience are expected to rise between 4 to 8%. So if your parents or grandparents ask if you're going to be able to get a job studying rocks, yes, you'll be able to get a job because there is a deficit and the employment opportunities are rising. Here is our core curriculum and a planned course guide on through your 4 years of your undergraduate studies. So I'll just go through the core curriculum real quick, and you can find this on our Geology and Geophysics website for Missouri S&T. So you have physical environmental geology. So that's going to be your start class for geology, getting into it. That's your intro class. You have Geology 1120, so that's evolution of the Earth and the lab that is associated with it. You'll have mineralogy and crystallography, which is super important on identifying minerals. You'll have igneous and metamorphic petrology. You're going to be studying rocks and how they form. Introduction to Geophysics. You're going to be working with Dr. Liu, Dr. Maurer, Dr. Gao, and learning these ways to interpret the world through geophysics. You'll have a seminar class where you get to sit through speakers that will speak to us for about an hour. You have structural geology, figuring out how all these rocks move and how they all fit together. You have stratigraphy and sedimentation, which is an important class on figuring out how sedimentary rocks form and the lab that's associated with that. You have introduction to geochemistry. So if you really like chemistry, this is the absolute place to thrive in right there. You have field geology, which is the intro or the prereq to the advanced geology field camp, where in field geology, you're going to get into the intro of how to take good field notes, how to use a compass, GPS, and in your advanced field geology, that usually requires you go out west and do all those skills that you learn in field geology, but at a much larger scale. So if you're interested in pursuing a geology and geophysics degree at Missouri S&T, apply for admission. Submitting an application is completely free. We are not going to be charging you to submit and to apply to our school. I think that is just absolutely crazy when schools charge you for that. Schedule a campus visit. Something that was really important to me was visiting the campuses throughout the colleges that I was looking at, seeing if it would work for me, including the town. Will the town work for you as well? More information about our department can be found at this link right here, the ese.mst.edu. If you have questions, feel free to contact us or drop a comment. We have Professor of Geophysics, Dr. Kelly Liu, her email address listed, and all the student ambassadors. Grant Clark, who's currently working on his PhD, is more than willing to answer questions. And us undergraduates, Kaylee, Justin, Kale, and myself are more than willing to answer questions for you guys. And I believe that is all I have for you guys. So thank you.